Okay, today we'll be doing electronics experiment 4. With this experiment, we're introducing a new component known as the diode. Okay, so for the diode, its basic function is to limit current flow into one direction. Now, the purpose of part 1A for this experiment, we're going to show how that current flow is limited to a direction with a simple circuit. Now, this simple circuit will involve an AC current from our breadboard going into our diode, which then goes to the resistor and out to ground. Now, what you'll see for a diode, that it's got this black line on the one side of it. Now, that black line indicates your direction of current flow. Okay, so the first thing we'll do is get our AC source correct. So if you remember from the previous experiments, we got our AC from this out point at the top of the breadboard. So we connect our red wire and then pick a point on your circuit board, okay? And now we're supplying our AC to that line of 6 holes there. Okay, then for our diode, which comes next, we want the current to flow away from our red wire. So we're going to place the diode such the black line is away from our current source. Okay, and then as usual, when we introduce a new resistor, if we don't know what the exact value is, we're going to use our multimeter to measure what the resistance is. So we can pick 2 random spots on the board again, just to make measuring easier. And then we bring our multimeter, set it to the correct setting. So we know the resistor should be about 15 kilo ohms. So I set it to the 20 level there. And then we just place our probes either side of the resistor. And we see our resistance. Is about 15.15, so we take note of that in our template. Okay, so now to complete our circuit, we connect the resistor to the other end of the diode. Then its output goes to its own voltage source, and then to complete the circuit, we're going to ground the end of the resistor. Okay, so now we have our complete circuit. We can turn it on. Then the conditions for our input, what we want to see is that we have a sine wave. Okay, we've got our sine wave here. We want to set it to maximum amplitude, okay, and a frequency of roughly 500 hertz. So to see what our frequency is, we can use our measure function again. We've got channel 1. We go to the time option, scroll down to frequency, and push enter. And now we can see our frequency. So if we adjust it, okay, so now we take note of what our frequency is. Once again, if we've got a little bit of variance in it, you can just stop it momentarily, record the value we've got there, and then just remember afterwards to push run. Okay, so now we've got our correct input and our circuit set up. So we're going to look at the output, which is between the diode and the resistor. So what we can see from our output here is we're now getting a half wave. We've got, when our input's rising to the positive region, we've got our output basically mirroring it, but then we see when our input goes to the negative region, our output just cuts out at 0. So we see it's only allowing current flow in the positive direction, but not in the negative direction. Okay. So you'd need to, for these results here, we want to see what our voltages are. So we can choose our measure function again. We're going to select our voltage. We want Vmax for our input, channel 1. Okay, and we also want Vmax for channel 2. So I change the source to channel 2. And then we go for our voltage, Vmax again, clear our menu. Okay, so you're going to record your Vmax for input and output, and also take a picture of what you see on the screen. Once again, if it's moving, you can stop it, record your measurements, take your picture, but just remember to run it again once you're done. Now, what we're going to do next is we're going to see the effect we'll have if we switch the diode to the other direction. So all I'm going to do is turn the diode around. So now the black line is pointing towards our AC input, the red wire, and then the other side goes to our resistor. Okay, we plug back into our input for channel 1 and our output for channel 2. Okay, so now we see we've got the opposite. When our input is positive, we just get the flat line along the 0 axis for our output. But then when our input is negative, we get the replicate or almost replication. As we can see, there is a slight height difference. Okay, now we're going to change our measurements. We just want to, we can keep the frequency and the Vmax of the input, but now we want to switch to our Vmax, Vmin of our output. So we go to our measure. Unfortunately, we need to clear all of them again. Go to source, channel 1, frequency, then voltage, Vmax, and then source channel 2. Voltage, and now we want Vmin, so we scroll down. Okay, then we can freeze the image. Then you'll record your Vmax for your input and your Vmin for your output, as well as take a picture of what you see on your oscilloscope screen. Okay, then for the next part, we're going to switch the order of our diode and our resistor. So now the resistor will come first. Okay, and then for our diode, we want the current to flow away from the resistor. So we're going to place it such that the black line is towards the grounding brown wire. Okay, then we just plug in again. Input for channel 1, output for channel 2. Okay, and now we'll see for this one is that we basically get the same sort of shape as our previous configuration, where we had the resistor pointing towards the red wire, the diode pointing towards the red wire, and the resistor after it. But now the slight variation we can see here is instead of the output lying exactly flat on the x-axis, the 0 line, we've got a little bit of a bump there. Okay, so to measure for this one, what we're going to change is we'll clear our measurements again. Now we want to see what our Vmax for our input is, our Vmax and Vmin for our channel 2. Okay, so you'll take a note of these readings on the bottom of the screen, okay, and then we'll also take a picture of our output. Okay, then the final step of part A is we're just going to swap the configuration or direction of our diode around. We'll just turn it, so now it's pointing towards our resistor or away from our ground. Okay. So now we'll see what we get, is we get the positive region is replicated, but we'll see in the negative region of the input, we got this little divot here, instead of a flat line along the 0 x-axis here. Okay, so we can freeze it. You'll record your values again, and then take a picture of what's shown on your oscilloscope, and that'll complete part 1A. Okay, for part 1B, we're going to bring in a second diode. So the circuit we want to set up now is we're going to have our AC source from the board again, plug into a point along our circuit, okay. Then from the voltage of this red wire line, we're going to connect our 15 kilo ohm resistor from part 1A. Because we've already measured the voltage of this resistor, you don't need to do it again with the multimeter. Okay. Now for the output of the resistor, we're going to have our first diode. We want this diode here to point away from the resistor, so the current will flow away from the resistor. So we just plug it in. Okay. And then for the second diode, we want our current to flow towards the resistor. So we're going to place it such that the black edge is connecting to the line of the resistor, and then the other side goes to its own voltage line. Now what we're going to connect these diodes to is, for the upper one, is going to go to the variable DC of our breadboard. Okay, and then to start off with, the lower one is going to go to a grounding point. Okay. Now in terms of our AC input, it's exactly the same as part 1A, as in maximum amplitude, sine wave, and a frequency of 500 hertz, so we don't have to change that. Okay, then for our input, or channel 1 probe of our oscilloscope, we can just plug it in to the voltage line of the red wire and the input of the resistor. Now, with our second probe, what we first need to do is adjust our variable DC input of the pink wire until we get to 0 volts. Okay. So if we'll see there, this black line is currently our output, which is our probe is measuring the pink wire. So if I use the measure function, we want channel 2, voltage Vmax. Okay, so I'm just going to turn this right down to its minimum, okay, which is approximate, well, 0 volts, okay, and then we move our output probe to where the resistor and the two diodes meet, and we take a look at what our picture is. Okay, so what we need to have on the screen, besides having the Vmax of the output, we also need its minimum. Okay, and then we also want the Vmax of our input, channel 1. Okay, so you're going to record these three results in the table you're provided with. Okay, and then we also want to take a picture of this here, what's on the screen. Okay, then the next step is we want to adjust our pink wire, or the upper diode, to 1 volt. So we'll just turn our knob until we get that Vmax 2 there at 1 volt, or as close as we can. If you can't get the exact value, just get close, but make sure to record what you use. So in this case here, it would be 1.04 instead of exactly 1. Then we just move our output probe back to where the three components meet. Okay, and then we'll see here our output slightly changed because of that variation in the pink voltage. We'll record our values. Okay, then the next step is just to show one more. We're going to adjust our pink wire voltage to 2 volts. Okay, move it back to where the three components meet for our output. You're going to record the three values on the screen as well as take a picture of what you see here. So we're going to increase our pink voltage in steps of 1 volt up to 6 volts. And for every voltage, you're going to record the values, but you only take pictures for the even values, such as 0, 2 volts, 4 volts, 6 volts. Okay, so once we've got to that part, we're going to leave our pink wire fixed at the 6 volt region. Okay, and now what we want to do is start varying our white wire or the lower diode. Okay, so that one we're going to move to now the negative variable DC. And we'll start at negative 1 volt. Okay, once again, if we can't get exactly, just make sure you record the value you do get. Okay, so we've adjusted that to negative 1. We're going to move to the output. Okay, you'll record the values at the bottom here, Vmax and min for your output and Vmax for your input, and then we'll take a picture of what's on the screen. Now, just like with the pink wire, for the white one, we're going to decrease our voltage in steps of 1 volt from 0 all the way down to negative 6. And then in this case, you're just going to take pictures of the odd voltages of your white wire. So negative 1, negative 3, and negative 5 is where you'll take pictures. But you do need to record the bottom values here in the table provided for every of the white voltages. So now for part 2A, what we're going to build is what's known as a half-wave rectifier. And able to do that, what we'll need is the 15 kilo ohm resistor from before. Since we've already measured its exact value with the multimeter, we don't need to do it again. We'll need our diode, and then finally, we'll need a 10 nanofarad capacitor. Okay, so the circuit we'll set up here is, once again, it's going to be an AC voltage from the out points of our breadboard connecting to a voltage line on the circuit board. Okay, then we're going to take our diode. What we want now is to connect our diode to that voltage line, and we want the current to flow away from the red wire or the input. So we're going to place our diode such that the black line is further away from the red wire. Okay, then the next step is we want to place our resistor and our capacitor in parallel. So what that means is they'll both have the same starting point, which is the output of the diode, and the same ending point, which will be grounded. So just to verify, we've got our AC flowing in to our diode, which is pointed away from the input. Okay, and then we've got our resistor and capacitor in parallel. They both have the same input from the output of the diode, and then they both have the same output, which is grounded. Okay, so that's our circuit. Now for our input, what we want to do is we're going to keep it on the sine wave at maximum amplitude, but now we want to vary our frequency. So the starting frequency is going to be roughly 250 hertz. Okay, so our input will once again be channel 1, and we're going to connect that to before the diode and where the red wire meet. And then our output is going to be where the three components meet. Okay, so then all we're going to do is for this one, we'll clear our measurements and pick new ones to follow. So what we want is the frequency of our input. And then for our output, we want our Vmax and our Vmin. Okay. So we'll start at this point. You're going to record the values you have here. Okay. And then we're going to increase our frequency to 500 hertz. Okay, so once again, if we get a little bit of fluctuation, we can just freeze the screen. Now you're going to record these values, frequency of the input, as well as the Vmax and the Vmin of the output. Okay, and then you're also going to take a picture of this one here. Okay, then we run it, and we're going to increase our frequency to roughly 750 hertz. Okay, we'll record our values again, and then all we're going to do for this, the rest of this part, 2A, is we're going to increase our frequency in steps of roughly 250 hertz, all the way up to 24 kilohertz. And only for the multiples of 500 will you take pictures. For the rest of them, you're going to just record the three values at the bottom of the screen in the table provided. Just to show what the maximum is going to look like, if we go to the 24, so this will be your ending point where your frequency is roughly 24 kilohertz. You'll record this, and since it's also a multiple of 500, you'll take a picture of this final one here. Okay, then that'll complete part 2A. Then for part 2B, that's going to be a theory question because we don't have the equipment to do a full wave rectifier. So further details will be provided to you at a later point. Okay, so now to the final part of experiment 4, part 3. What we want to do is just have a quick look if the type of input we apply to the circuit will have any change to our output. So what we're going to need for that is once again the same 15 kilo ohm resistor from the first two parts. Since we know what that exact resistance is, we don't need to measure it again. Okay, and then we'll need two diodes. One's going to be pointing away from the resistor, so we want current flowing away from the resistor, and then the other one's going to be pointing towards the resistor, so we want current flowing to the resistor, and then both of those outputs will be to ground. Then for the input of our circuit, AC once again. Okay, so we want our amplitude at maximum and our frequency at roughly 500 hertz. Okay, channel 1 of our oscilloscope will be our input again, which is where the red wire and the resistor meet. And channel 2, our output, will be where the three components meet. Okay. So if we got there, what we want in our screen is the same values as we had for part 2A. So a frequency of our input, our Vmax and our Vmin of our output. Okay. So all we're going to do then is get our frequency close to 500 Hertz. Okay, so we've got our first one is set to the sine wave. So we're just going to take a picture of what we see on the screen, including the values we get. We can freeze that if necessary. Okay. Then the change we're going to make is just go to a triangular input, freeze that, take a picture including the values of what's on the screen, and then finally we're going to go to a square wave, freeze it, take a picture including the values of the screen, and that completes part 3 as well as the entire experiment 4.